In building new homes, a contractor finds that the probability of a home buyer selecting a two-car garage is 70% and selecting a one-car garage is 20%. Now notice you can't have both a one-car and a two-car garage, right? So there's no overlap for this. So if I drew myself a Venn diagram, which I really don't need to here, but this would be the two-car garage, this would be the one-car garage. There's no overlap, so this is 0.7 and this is 0.2. So notice there's no three-car garage. So that means you might not buy a house that has a garage at all, right? 70 plus 20 is 90, so there's a 10% chance of not having a garage at all. So what's the probability that the buyer will select a one-car or a two-car garage? Well, that's 70 plus 20, so that's 90%. Find the probability that the buyer will select no garage. Well, that's the 10%. Find the probability that the buyer will not want a two-car garage. Well, if I don't want a two-car garage, that means I'm not in this group. So I could be here or here. So I'm not in the 70% group. So I either want a one-car or a no-car garage. So that's going to be 0.3. Suppose, let's see, what do they tell us up here? Researchers are interested in the relationship between cigarette smoking and lung cancer. Suppose an adult male is randomly selected from a particular population. Assume the following table shows some probabilities involving the compound event that the individual does or does not smoke, and the person is or is not diagnosed with cancer. So we've got this table. Smokes and gets cancer, smokes and does not get cancer, etc. So now it says, find the probability that the individual gets cancer given that he is a smoker. So we're saying probability that he gets cancer given that he's a smoker. So remember the formula for that would be the probability of cancer and smoking divided by the probability of smoking. Okay, so A and B divided by B, right? So cancer and smoking, that's 0.08. Probability of smoking, that's 0.25. So we've got 0.08 out of 0.25, which is 32%. Find the probability that the individual does not get cancer given that he is a smoker. So we're going to say probability of no cancer, right? Cancer complement, given that he's a smoker. So smokes and does not get cancer, so that's 17% out of 25%. So that's 0.17 out of 0.25, which is 68%. Now, notice those add up to 100% because now we've talked about what can happen to you if you're a smoker, right? 32% chance of getting cancer, 68% chance of not. Find the probability that the individual gets cancer given that he does not smoke. Well, if I've got a 25% chance of smoking, then I've got a 75% chance of not smoking. So the probability that I get cancer given that I'm not a smoker, so that's going to be does not smoke and gets cancer. So that's 0.04 out of 0.75. So, oh, did I do that right? Does not smoke and does not get cancer. Does not smoke and gets cancer. So 4%, yeah. So 0.04 out of 0.75. So that's a 5.3%, 0.053. Find the probability that the individual does not get cancer given that he does not smoke. So does not smoke and does not get cancer. So the probability that I do not get cancer given that I do not smoke, so that's going to be 0.71 out of 0.75, which is going to be all the other non-smokers. And so that's 0.946, 0.947.